Thank you very much for coming, guys. It's a massive blast and massive honor to be in front of such an amazing audience. You always motivate us to be the best versions of ourselves when it comes to the products that we provide, presentations that we prepare, and we are here for you. So if you have any questions at any point, ask after the presentation.
Hey, Mac, now you think they're warmed up, do you think they're ready to do that thing we wanted to do?
You think? Okay.
Probably. All right, let's see. Well, during our first part of our presentation, you know we love audience participation. We actually have members of the Ekahau team all spread out throughout the audience, and we're going to be giving away some swag. But we wanted to do something before we start our presentation that we want your help with. You'll know exactly what we want you to do when we do it, but we're going to make a little video, and the louder you go when we come to you, the more chance you have of winning a swag item. Are we all ready?
Born ready, man. Let's do it.
Okay. Let's do it. We'll see it go on it.
Not a photo, a video.
Yeah, okay. Mac, how excited are you for Wi-Fi Design Day today?
I am so absolutely blastingly excited. I will not be able to sleep for the 10 years.
Okay. Maybe we should ask these guys and girls, how excited are you today for Wi-Fi Design Day London? Woo! You better get on with the show then.
That was amazing, guys. That was amazing. I love the energy.
All right. Okay, so we all love you at Wi-Fi Design Day London, and because we're in London, we wanted to do something a bit special and unique for here. And if you're from the UK, I'm sure everybody is familiar with Cockney rhyming slang. I know there's a lot of people from America and Europe. You might be thinking, oh gosh, what is this about to be? But effectively, it's two words put together. When you say it, it kind of rhymes. So if I said to you, Mac, go careful going down those apples and pears, you'd say? Stairs. Okay, fantastic. So I thought, why don't we come up with some Wi-Fi rhyming slang? If you know the answer, shout it out and you will be given a piece of swag from someone in the audience, okay? So we're going to show you what it is on the next slide, and if you think you know what it is, just shout it out and then you're going to get a free swag item, okay? So first one, if you're ready, bridal flannels.
Channels, we had a winner there. We had a winner there. Winner is there.
Free swag over here, everybody.
There we go. Well done, Miko.
Okay, channels.
Finally serving purpose.
And if you were wondering, how can I drop this into my next customer meeting or playback? Looks like we need to change the bridle. Too much noise on this one, so feel free to steal it if you need. Okay. Mac, okay. What about the next one?
Let's try the next one. So the next one is dentist convention.
Contention, there's a lot of people that said it. If you've said it, put your hand up and let's get some swag over to these people. Well done, everybody.
Mika, and you can throw it.
Be careful. Okay. So
how do you use dentist convention in a real-world Wi-Fi scenarios? The network's slow due to too much dentist. And everyone knows what it means, right?
Who's writing this down to use for their next playback, right?
Yeah, I'm sure it goes into next report.
Third and final one, okay? This will be quick, I'm sure. I hope. Ready? Ride quick. Sidekick!
Well done.
Yeah!
So we had somewhere in the middle and somewhere on the right-hand side.
Perfect. And then, yeah, let's use the ride for the site survey for how we're going to drop it into the conversation. Okay, we had a bit of fun, and what we're here to present to you today is actually how we transformed the Wi-Fi with L'Oreal at their largest distribution warehouse, which is over in Germany, which was 1 million square foot wide. And if you want to try and comprehend how big that is, 10 football fields large, so it is a really massive warehouse.
But it's not just massive, it's full of challenges, unique challenges to the warehouse environments or pretty much any industrial environments that you might find out there. So think of very, very long aisles, very high racks, very high attenuation, very bad roaming for the devices that are on wheels. So in this particular warehouse, we have some distribution techniques where you have tons of products on a cart and you have scanning devices on the cart and they move from one side to the other while scanning all the time, and when the roaming is bad, everything stops. They have to wait for the device to connect back to the Wi-Fi network, and it's not ideal. Additionally, we have very high ceilings in this warehouse, so you need to start thinking about how to cover where the clients are. You don't need to cover the ceiling with the omnidirectional antennas. You need to cover where the clients are. And also massive, humongous open spaces where we have parking areas where you need to be careful with how you propagate the signal, so not every single access point blasts across entire area. We want to contain the CCI. We want to contain the contention, right? So the design is quite challenging and it's different for different areas. So let's take a look at the requirements, which is the most important part to start with.
So when we had the conversation with L'Oreal, we really needed to understand like, what are they looking to achieve from this new Wi-Fi deployment. And this warehouse was going to be the blueprint for all of their other warehouses. So it was really key we got this one right. And the thing that they really hammered home to us was it needed to be completely future-proofed. So this will go in, it will be running for the next 5, 6, 7 years. It has to support all new technologies, devices coming to the market. So for us, we translate that and we say, okay, that means they're going to be needing to put in 6 GHz capable access points. So fully supporting 6 GHz, they had no legacy devices in the environment. So no scanners or mobile devices that were supporting 2.4 GHz. So at a very worst case scenario, they'd be supporting 5 GHz. Roaming is super important because Max said they've got lots of these devices running around the warehouse, phones, scanners, machinery, everything completely mobile, no cables, needs to have seamless roaming. And from a RF perspective, they needed redundancy. So if they lose an access point due to faulty AP, cable, et cetera, there had to be redundancy. So we needed to factor in all of their current challenges, plus all their requirements to come up with a new design for them.
Okay, so we have multiple different areas in the warehouse. So the area marked in green is the high racks, massive racks, 100 meters long, 13 meters high, and then the area marked in blue is the parking area there. So open space, just conveyor belts and nothing else, nothing stopping the signal propagation. The highlighted orange, will be highlighted in a second, is the mezzanine floors where we have no walls whatsoever. So when we place, let's say, Omnis on the second level of mezzanine, it will cover, every single access point will cover pretty much the entire warehouse. So we don't want to have that, and then areas in red were excluded. So let's talk about the best practices for the design.
So L'Oreal, the vendor of choice they have is Cisco Meraki, and the access points we're going to use them. We actually, I'll be honest, we got kind of lucky. And the reason why we got kind of lucky is because when we got engaged with L'Oreal to do this, right at the time we was about to go to the site was just when Cisco Meraki was launching their new access point called the 9166D1. And if you don't know why this is kind of helpful for this scenario, is that with 6 GHz, with the low power indoor rules at the moment, you can't have detachable external antennas. So why would that be a problem if you're designing a warehouse? Want high gain, you want to focus the energy of the RF in specific places, the aisles, the open spaces. We need to use external antennas. So if you want to go fully future-proof 6 GHz, we needed a way to be able to do that. And the D1 actually has internal directional antennas to the access point. So we're going to leverage that, and we managed to get our hands on one pretty early to go there and test with. So we plan to use that directional inbuilt antennaed access point for most of the spaces. And then in the typical kind of like office spaces or some of the mezzanine spaces, we're going to use the internal integrated omnidirectional antennas.
Okay, so let's talk about the first of the areas, about the high racking areas. You have multiple different solutions that would work in these areas. You can shoot from the top and light up entire aisle. You can shoot from the sides. So looking at the access points that we had available, which is 9166D1 with fairly narrow coverage pattern. It's not super narrow, so it probably is not the best to shoot from like 13 meters down. So what we've decided to do is to have two of these APs on both sides of the racks and tilt them down. So based on number measurements that you will see in a second, when you walk down from one side to the other side of the aisle, your device, and it doesn't matter what device it is, any device that they are using in a warehouse, which is either a mobile phone, tons of mobile phones with soft phones in the warehouse, so voice is important, or the stuff on the wheels, they will roam around 60–70% down the rack. So based on number measurements, we've decided to put these antennas down, like tilt them down by around 30 degrees. That enforce a very good, predictable roaming for these devices. Also, transmitting power levels, we try to match the transmitting capabilities of the client. There is no reason to go too high, and there is no reason to go too low. Actually, you can't go too high with the directionals not to break the regulatory rules, so you need to understand what is achievable in your area, making sure that you don't break these rules. And also, we've mounted the APs at 5 meters high, and we'll talk about it in a second as well.
So the other space we wanted to use that same model access points for antenna was actually where there was going to be the large open spaces. So there was these pallet areas and there was no high racking aisles to attenuate the Wi-Fi. So what we wanted to do here is use the access point and suspend it down from the ceiling and focus that energy down at a certain part of the open space area, really to keep control of the RF, because if we use omnis here, it would just flood that whole space and we can't control the cell size. So this is what we wanted to achieve with this, and we was going to drop it down via a drop pole and suspend it down to roughly around 7 meters height. So that was our plan with the predictive design that we did in Ekahau before we got to site.
Yeah, every time he talks about Paul, I think he talks about me because I'm from Poland, right? Okay, guys, so then we had a ground floor, a mezzanine floor, which is fairly high, but not too high, like around 5 meters above the ground. So we had a choice of directional antennas shooting down or omnidirectional APs, but we understood that there is no requirement for capacity in this area whatsoever. It's full of like paths where the guys or girls picking up things they will have to take in order to get from one side to the other. There is like a lot of blockages on the path where you will never have too many devices contending for the airtime, connecting to Wi-Fi. So we have decided to use good, plain, old internal omnidirectional antennas because they were covering a lot and we wanted them to cover a lot in this scenario. So with just 2 antennas, we were able to cover entire under mezzanine floor.
So another kind of like unique space was the first floor mezzanine, and why that was a little bit unique is because the way that the first floor mezzanine was constructed is on the side closest to the car park. It was obviously like a big concrete wall, but the wall where you would expect to be towards the main shop of the warehouse, they actually didn't have any kind of wall at all. So if we mounted a omnidirectional access point on the mezzanine floor, that would actually bleed so much out into the main shop floor of the warehouse. It would create so much contention. You'd have devices connected on the ground floor to the first floor, access points by the mezzanine, and we just wanted to avoid that as much as possible. So again, using the D1 in not the most conventional way, by putting it on the ceiling and focusing it down, provides good coverage, controlled cell size, and limits the amount of contention out on the main warehouse shop floor.
And before we switch to the next slide, okay, too late. Is there any scenario, guys, where you would put an access point with omnidirectional internal antenna on the wall like a clock? Stairwell.
You saw the slide.
Yeah, you saw the slide, I'm sure.
My fault, my fault.
So yeah, so that's exactly what we did. We wanted to cover the staircase down and up, and that is why we put the internal omnidirectional antenna on the wall, and the propagation pattern from this AP is a little bit forward in front of the AP and around, so it's absolutely perfect to cover the staircase.
Yeah, so if you haven't noticed, we get a little bit excited about Wi-Fi and Ekahau and the fact that we was able to now test a directional 6 GHz access point and antenna on site. We were pretty excited. We went to this warehouse in Germany. We got one of the massive Vantage tripods so we could actually put the access point up at the height we was planning to install it. Mac mentioned earlier, the reason why we went with 5 meters height is because if you can see, if I do the fancy thing with the clicker, that's the mezzanine floor. So by the way, you see here how there's like no wall at all to like block the signals coming into the warehouse, but that's the floor of the mezzanine floor where we can mount access points on the other side of the main long racking aisles, and that was at 5 meters. So we wanted to match that on the other side of the warehouse. So that's why we went with 5 meters, the angle of tilt we did. But the key thing is, whenever you're doing a Wi-Fi design, deployment, validation, you always need to go on site, test and measure to make sure it's going to be as you expected it to be. So that's what we did here. We had an Axeltex battery pack, thank you very much, Axeltex, and we had the Vantage tripod to go up to 5 meters. And then we simply got our Sidekick 2s and our iPads and we went for a walk.
Exactly. So guys, now based on the measured data from AP on a stick, and let me emphasize it because it's very important, the sole reason for doing AP on a stick survey, measured survey, is to make sure that your predicted model reflects the reality, okay? So you might have created your predictive model before going to the site, and it might be very good, but probably it will not be perfect. That's where you take your AP on a stick, your Sidekick, you walk around, you understand the attenuation of racks, attenuation of walls, the reflections, you understand the environment, how the RF waves propagate for all the stuff in the environment, and based on that measured data, you update your design to make sure that it matches the reality. So what we have changed the attenuation value of walls, of racks, height of racks. We had wrong height of racks in our floor plans, and it also changes how the RF propagates. And we also relocated, not massive amount, but a fair amount of access points to make sure that we cover what we want to cover exactly where the devices are.
What we want to show you here is the results from what we have measured with the Sidekick 2 on our access point on the stick that we had in the warehouse, which is on the left-hand side. And if you compare that to the simulation that we did in AI Pro, so our model, what you can see is just how accurate and similar the heat maps are. So if you look at the green and the yellow coverage, you can see what we found on site actually completely matches what we have in our model. So that was really reassuring for us to see, because that then gives us the confidence to know the design that we've done in our model is going to be reflected what actually gets installed on site, and we know that they're going to have the exact coverage and connectivity that we had planned for. But we did have a question, especially when 6 GHz was first coming around. I know a lot of you probably also had this question as well, is what is going to be the difference between 5 GHz signal versus 6 GHz? So we had that same question as well, right? And we wanted to know, what is it going to be?
Yeah, so what do you think, guys? What is the difference when it comes to the propagation between two frequency bands, 5 and 6? Same AP location, same device measuring it, a Sidekick, for example, same distance from the access point. What would be the difference?
What would you expect the difference be in like a dB level between 5 and 6 GHz? Slightly less, you said. So 6 GHz is going to be slightly less than the 5 GHz. How many dBs do we think, roughly? 5, 6, 3? 1 to 2? Okay, we're getting some variations of what we think it could be here, but we had the same question too. So what we did is we wanted to make sure the access point on the stick we had on site matched how it was configured in our simulation as well. So what we've got is on 5 GHz, the AP on channel 36, 20 MHz wide, 14 dBm transmit power, and on 6 GHz, channel 5, 20 MHz wide, and 14 dBm transmit power.
Exactly.
And Mac, when you look at, and that matched in our predictive model what we did too, same tilt, everything is matched the exact same. But Mac, why did everyone most think 2, 3 dB difference?
Very good question. So 5 GHz has around 500 MHz available spectrum. 6 GHz in States, cheaters, has 1.2 gig. In Europe, we have 500 megs, thinking about extending it to 1.2 gig. But if you look at the States, for example, where you have 500 megs on 5 GHz, 1.2 GHz on 6 GHz, and look at the central frequencies of the available frequencies in these two bands, we will have 2 dBs of a difference. Of course, the last channel on 5 GHz is adjacent to the first channel in 6 GHz spectrum band, so then the difference will be negligible. And if you look at the entire spectrum, it will be more than 2 dBs. But we were statistically expect to see 2 dBs difference between the frequency bands. So let's take a look at some fancy things.
So this is the simulation now in Ekahau AI Pro, and it's the same D1 access points on 5 GHz versus 6 GHz. So I had configured this, and what we did is we're going to test and look at the data between 4 different data points at 20 meters, 50 meters, 70 meters, and 100 meters. But what do you notice here? The 6 GHz is slightly lower, well, stronger signal strength, so lower signal, 53 dBm versus 5 GHz. So I was looking at this and scratching my head, and I called up Miko. And if you don't know Miko, he's our VP of software products. I was sitting down, hiding over there, and I was like, hey, Miko, I think we've got one of those unexpected features again. And if you don't know what an unexpected feature is when you work for a software company, that's another word for a bug. And he was like, I was so tempted to try and do the accent then, but I will not do it. But he was like, hey, Matt, actually, we haven't got an unexpected feature. You're the dummy. If you take a look at the antenna gain of the access point, I don't know why it's not loading. Don't know why it's not loading here. There we go. The actual 6 GHz antenna gain compared to 5 GHz is actually nearly stronger by 2 dBis. So that's why we were seeing a stronger signal strength on 6 GHz. So there wasn't a problem with AI Pro. It was me not looking at this and not knowing. So I let Miko off the hook. So again, looking at the simulation versus the 6 GHz versus 5 GHz, that's what we was expecting in our AI Pro, but then we went and looked at the data that we measured with the Sidekick 2, and on 5 GHz and 6 GHz is actually the same results. So what we was expecting was minus 54 dBm and minus 53, and what we measured with the Sidekick 2 is the same, which was pretty cool, right?
It's super cool, guys. And also, like, we have a conclusion in the last slide in this section that shows us why it's so cool. So the simulated was what Matthew has shown versus measured at 20 meters away from the AP, it was a match. And now 50 meters away, we have 5 GHz minus 62, 6 GHz minus 61. So still 6 GHz is a little bit higher up by 1 dB. So that was simulated. Now measured, when we measured it exactly in the same space, in the same point, 50 meters away from the AP with Ekahau Sidekick 2, we had plus 1 dB on 5 GHz and the same RSSI measured on 6 GHz, so very, very, very accurate simulation.
Yeah, so then at 70 meters, we was expecting around minus 65 on 5 GHz and minus 64 on 6 GHz, and when we measured that, it was actually very close again. So -1 on 5 gigahertz and +1 on 6 gigahertz. And bearing in mind that this is a very highly reflective environment, this +1 -5 on 5 and 6 gigahertz is actually really, really good.
And finally, 100 meters away, we were expecting NEC 68 on 5 and NEC 67 on 6 gigahertz simulated. And when we measured it with Ekahau Sidekick 2, we had a 2 dBs difference on 5 gigahertz and exact same measurement as in a simulated environment with a Sidekick 2. So the conclusion, the biggest thing is?
The simulation matched measured, and when we were speaking to Ari and Miko and stuff like that, that's really what our Sidekick 2 to be, is as close to free space path loss as possible. So it was really good to see that what we had simulated and what we were expecting to see is actually measured and matched. But we did not want you to leave this presentation thinking, do I not need a Sidekick 2? Of course you need a Sidekick 2. Actually, you probably need to buy 10. There's some salespeople here if you will probably come and try and find you. But no, the reason why you still need a Sidekick 2 is because this is unique for us in our environment and what we tested, the channel, the access point, the antenna gain, everything that we did to make it accurate.
But that's not everything. It's like, how do you think we get to the point where our simulated environment was the exact representation of the real environment? This is because of an AP on a stick and measurements with a Sidekick. So that's how we get there.
And your designs, your access points, your client devices, they're all going to be different, unique environments. So you should always go and measure, test with your real world examples, devices, and make sure they match what it should be.
Okay, so now guys, like this warehouse was absolutely massive, right? So imagine one person having to go there and survey it like 3 times to get all the information that you need and prepare the design and optimize the existing environment. And every time you walk around is 40 kilometers, that would be a little bit pain in the backside, wouldn't it? So we divided and conquered this environment. All of us, like 4 engineers, we had our sidekicks, we had our iPads or iPhones. We started in different corners, met in the middle, and then the second that you finish your survey, and you save it, all the results from all the different survey engineers are saved to the cloud and merged into a single project, and you can see different survey paths done by different survey engineers. So that is very cool.
Yeah, Mac, and we're so good at marketing now, I'm sure the audience won't notice if we try and plug a new licensing model we've just come out with. So if you haven't heard of this, we have launched a new SaaS-based survey-only license called Measure and Measure Plus. So exactly what we just did at the L'Oreal warehouse, if you wanted to be able to do that capabilities too, if you've got maybe members of your team that don't need to access the full functionality and features of Ekahau and AI Pro and Insights, etc., and you just need to collect survey data, you can now use this Measure license or Measure Plus. The difference is if you already have a Sidekick or a Sidekick 2 and you just want to get the software only, that's Measure. If you haven't got a hardware measurement device and you need the Sidekick 2, for the same price as what the Sidekick 2 was to buy before, that now actually price includes 1-year license for an Ekahau Measure survey-only license too. So dividing and conquering massive surveys like we did with L'Oreal, achievable with this too. So fantastic new license model there. Did we slip it in okay? I don't think they noticed, right?
No, of course no one noticed, man. Okay, so so we talked about the design quite a lot. So now let's think about what do you do with the existing environment in this beautiful massive warehouse. So we knew that we had some challenges when it comes to operation of the Wi-Fi there, and we wanted to kill 2 birds with 1 stone. So since we already have the survey data, we walked around a few times, we have redesigned the space, we placed an order for the access points and for everything else. Now let's fix what we already have, shall we? So just by walking around, we have locations of the APs. Some of the locations we had to move to the real locations, like plus minus few meters because of some directional antennas and stuff. But this is the existing location of the existing access points in this warehouse. Now, what do we do with this stuff?
Yeah, so a feature that I'm not sure if everyone's familiar with is really helpful when you're doing this type of survey is actually taking notes, assign it directly to the access point. And there's a lot of things you can do with this. Once you've taken the AP note image picture, it's tagged with the access point. So if you run a custom report or if you push it to some of the vendor dashboards, that information can get automatically pushed. And it just gives you that context to understand how the actual physical environment is, and you can scribble in it, make notes, and it's a really handy feature.
Okay, and now guys, like this is a massive thing, okay? So since you already walked around, you have measured survey data, you can just upload that thing, the measured survey data, to the cloud, and you can let Ekahau Optimizer shout out exact recommendations about what to do in your network to fix it without having to redesign it, okay? So of course, not always you will be able to fix everything without a full redesign, but since we are still waiting for the APs to be delivered to us, why not do the best that we can to get the most out of the existing network while we wait. And we also can pick in the future, so when you implement changes like channel changes, channel width changes, transmitting power changes, minimum basic rates changes, actually your coverage might look a little bit different. So you can see before and we can see after, and that's without doing a redesign. So that's a great thing, isn't it?
Yep. So we just wanted to cover quickly the different types of surveys that we did on site. So we're going to fly through these. Basically, we walked the site a few times, and the reason why we did that is because to get like the pre-design, we wanted to capture accurate survey data, which is where we see all of their existing access points. We can look at that results, the heat maps, attenuation, update, our predictive model, and it helps us discover what's going on in the environment.
Yeah, and then we walk around for the second time doing a second pre-designed survey where we pinpoint the exact location of the EP. So Ekahau will be fairly accurate because we use RSSI to locate the EPs. You will move them to the real location because you might want to reuse the cable runs for your design later on, right? And also we will use the survey data to export the location and floor plans from Ekahau straight to the dashboard of the vendor of your choice.
Yep, and then Mac mentioned that once we have that survey data, we have something we can optimize and improve the existing Wi-Fi. So we use Optimizer to improve it whilst we're waiting for the new network to go in. So really great functionality that we had there. So we wanted to show you what our final design actually looked like for the warehouse. So all of the blue and the green access points that you can see, they're the 9166 D1s, and they're being used in those slightly different ways where it's pointing down the aisles or pointing straight down at the floor, and the breakdown of the access points, we had 211 for the design, and actually out of the 211 is 190 was the directionals, and the other 17 and 4 was the internal omnidirectional access points.
I just wanted to give a quick shout out to Cisco here because 9166 D2 is coming, and it will be even more directional. So that will be fantastic for warehouses like that as well.
This slide we're not going to talk about, but we wanted to make sure you had some tips for how we're going to be configuring the warehouse Wi-Fi. Feel free if you want to snap a photo of it, but obviously it'll be in the recording and you'll be able to get it when you watch it back too. But obviously the important part as well is not just to the design and the surveys, but how we're going to be configuring the Wi-Fi in the warehouse too to make sure it has a good performing network. So that's our tips for the configuration. And
yeah, guys, I'm sure that most of you are familiar with the autopilot where you use Apple ARKit to automatically locate yourself on the floor plan that you uploaded and scaled. But if you thought that was cool, look at this. So now you can just go. So you connect your Sidekick to a survey device of your choice. It must be Apple device to go for just go because it uses Apple ARKit, the LiDAR and the arrays of sensors from Apple ARKit. You can walk, you can run, you can use one wheel, you can use Segway. Keith likes Segways, Dan likes one wheels, Matthew likes to run, I like to walk because I'm not as fit as Matt. But you don't need to have any floor plans, you don't need to have any laser measure tools, nothing. You just go and you create the floor plan, the sketch as you go. So this is very cool. But this is not just cool for the sake of coolness. What can we do with this data, Matt?
I wanted to give you a really good practical example of how a friend of mine, I know he's in the audience today, that is happy to share this story with us of a use case for the Just Go. And I've known him for quite a while now, and this was the first time I was impressed by something he came up with. Usually he underwhelms me a bit, but I won't go into that. He knows who he is. He got tasked with going to Germany to complete a design for a factory of the ground floor. So he was able to go on site, use the floor plan provided, do a survey, come up with a design, fantastic. The customer though, however, wanted him to do a design for the first floor, but unfortunately had no first floor plan available at all. Didn't have one, so what could we do? Thinking about our time doing professional services and surveys, it would have been a pain. What would we have done before? Try and build it in Paint, Excel?
I remember running around with a laser tool and Photoshop and trying to create the plan on the go. That's pain.
Yeah, so what my friend did is he did a Just Go survey of the first floor, and what it did is give him a really good sketch of where the actual walls were and the access point that was installed there, and you can see the survey path. But what he then did is he then imported that back into Ekahau AI Pro and drew the walls over the sketch and then replaced the sketch floor plan with a blank floor plan. And what you notice you're left with is actually a scaled high-resolution floor plan with the walls drawn and something that we could then do a design on. So he was able to survey and then do a design using the Just Go survey feature, but also provide the customer a high-resolution scaled first floor plan, which just wouldn't have had that available before. So that's a really great use case for that. And we have some secrets that we want to share with you. So this is something that's coming, that's very new. No one's seen this before yet. And but we love you guys and girls at Wi-Fi Design Day London. So what is it, Mac?
Yeah, guys, so you do Just Go, and then you convert the Just Go data to do Just Design, where you don't need to do any floor plans, any walls, any scale. You don't even have to draw the walls. We already have a full propagation model based on the survey data, and then we can use that model to start dropping access points in it. And Ekahau AI Pro software will be able to predict the propagation of your RF waves from your radios, antennas, simulated radios and antennas. So how cool is that, guys? Like, honestly, you don't need to draw anything, measure attenuation of anything manually. No manual work. You just walk around, just go, and then do just design.
Yeah.
I think it's a mind-bending thing.
Miko's over here. Mike, where are you? Okay. If you see these gentlemen at any point today, they did tell me before the conference, if you bribe them with some beer, they will show you some of these new features and products. If you want to see what's coming, we're not ready to show it on the public platform yet, but if you want to see a sneak peek and preview, find these guys and they will show you some of the awesome new features and stuff we've got coming very soon for Ekahau.
Yeah, Miko is so excited. He's just like, no.
Lastly, we wanted to end with, if you thought Just Go surveys were cool, well, who knows what we might have in the future. Okay, that's the end of our presentation. Thank you so much for listening to us.
Thank you, guys.